Now we will talk about law of conservation of momentum. Imagine these scenarios. There is a ball A of mass m1 traveling with initial velocity u1. There is another ball B of mass m2 which is traveling with a velocity of u2. Now first of all we will calculate the momentum of ball A before collision. Momentum of ball A before collision is m1 u1. The momentum of ball B before collision is m2 u2. Now this was before collision. Now we will talk about during collision. During collision, this is ball A, this is ball B. During collision, the ball A exerts a force F A exerts a force on ball B. Now, since these two balls are in contact, they will each exert a force on each other by Newton's third law. By virtue of this, the ball B will also exert a force which will be equal in magnitude but opposite in direction. We will call this force exerted by ball B on ball A. So the force exerted by ball A on ball B, we call it FA slash B, and in turn the ball exerted by ball B on ball A, we'll call it FB slash A. So these two forces are equal in magnitude and act in opposite direction and act for the same amount of time. The time t is the same for both collisions, is the same for both collisions, for the collision. Now we know that force changes the momentum of an object. Now the force exerted by ball A will change the momentum of ball B with respect to time, and the force exerted by ball B will change the momentum of ball A. Okay, so can we say that F exerted by ball A on ball B is equal to minus FBA, because we're taking this direction as positive and this as negative. You know that F is the rate of change of momentum with respect to time. Okay, now before deriving the law of conservation of momentum, we will look at after collision. After collision, the ball A moves with a velocity v1 of mass m1 and ball B moves with velocity v2 of mass m2. So momentum of ball A after collision is P equals to mv or m1, sorry, this is m1 v1, and the momentum of ball B after collision is m2 v2. So law of conservation of momentum. Law of conservation of momentum states that in an isolated system, the total momentum before collision equals to momentum after collision. How? We know that FA equals to minus FBA, because this force is changing the momentum of ball B, and this force is changing the momentum of ball A. These two forces are equal in magnitude but act in opposite directions and act for the same amount of time. You know that F is the change in momentum over time. Also, this is the change in momentum over time. Now, the change in momentum of ball A. The final momentum of ball A is m1v1. The final momentum of ball B. Sorry. This force is changing the momentum of ball B. So the final momentum of ball B is m2v2, and the initial momentum is m2u2 time minus. Now this force is changing the momentum of ball A. So the final momentum of ball A is m1v1 and the initial momentum is m1u1. With respect to time, so this is m2v2 minus m2u2 over t minus m1v1 plus m1u1. This t and this t cancel. m2v2 minus m2u2 equals to minus m1v1 plus m1u1. So m2v2 plus m1v1 equals to m2u2 plus m1u1. So this basically tells us that the total momentum before collision equals to total momentum after collision. So this is the momentum before collision equals to momentum after collision. So an isolated system in which there is no resultant force, external resultant force. Thank you.